Hi everyone, welcome to questions on percentage yield and atom economy. First question we have here is asking us to calculate the atom economy, the formation of 1-bromobutane. So 1-bromobutane is this product here. So that's our desired product in that equation there. So only a single mark. Now hopefully we know what the equation is for atom economy. If not, we're a little bit stuck on this question. We take the MR of the desired product divided by the MR of all the products that we have. So we've been told in the question that the desired product has an MR of 136.9, but I've also got some other products in there. I've got two more. So my KHSO4 is 136.2 and my water is 18. So my equation to work this out will be my desired 136.9 divided by 291.1. That's if I take all those three values that I've just worked out, add them all together, and then that's what that would be there. And then to get a percentage, got to times up by 100, so therefore that gives me 47%. Second part of the question is suggesting a reactant other than a different acid that can be used to improve the atom economy of making this same product by the same method. So what this is saying is we need to change this somehow. Like it says other than the acid. So I'm going to make bromobutane, we still need the bromo part in there, but it's just the potassium then that we need to change. So what would be a better thing to do is to take something that's maybe in the same group that just has a lower mass number. So something like sodium or lithium would be suitable to use. So I've got that bromine in there, but that just means when we have our other products, the potassium hydrogen sulfate, we then have, say, sodium or lithium has a lower mass number, so therefore we'll be dividing by a smaller number, so we get a greater atom economy. And we have the third part of the question here, asking us to work out the percentage yield to three significant figures. Now it's always good to go through and highlight key bits of information. So we have a couple of masses there. Now the first thing to do is the only thing I can actually work out is the moles of the two things, butanol and 1-bromobutane, because I've been given the mass in grams. So what I can do is simply go and work out what the moles are by taking the mass and dividing it by the MR. So I've got my two values there, worked out my moles. Now, got to just remind myself of what the equation is for percentage yield. It's my actual yield divided by my theoretical yield. So you need to make sure you have that equation, but it's something that you should have seen before back at GCSE. So if I then take my 1-bromobutane, divide it by my moles for my butanol, I'll find that I get 88.75%, but the question did say it wants to answer to three significant figures, so therefore it'll be 88.8. Okay, and here we have question 2. It asks which type of reaction has the greatest atom economy. We've got our 4 different types of reactions there. Now, ideally we'd have a reaction where we don't get a bunch of other products, because then we have to take those into account of all the products that we get, so we've got to divide by a really big number. So we really want to divide by the smallest number possible, so ideally we won't have that many products. So in terms of these 4 reactions here, the best one would simply be an addition reaction. We take something, we add two things together in an addition reaction, we then hopefully won't get many other waste products, so therefore we're dividing by a smaller number. So an addition reaction would give the greatest atom economy. Question 3, which reaction produces the smallest atom economy? The BaCl2. Now very quickly you just simply have a look down there and think, right, again, similar argument to the question we had before, is we want to have as fewer products as possible, so we're dividing by a smaller number. But we want the smallest atom economy, so always make sure we remember to read the question. We want the smallest atom economy, so we want to have a reaction that has a bunch of other products that we don't actually want. We want the BaCl2, so if I'm looking at this here, very clearly I can see that the answer would be C. And the final question here, again we want a reaction on ethanol, so ethanol is the focus. that has the lowest atom economy. Now, you may need to go through and actually maybe do some quick calculations, just totting up the MRs of things, seeing which has the lowest atom economy. So you can see here that the B would be the highest atom economy, so you can probably cross B out straight away. The other ones, they need to then work out the MRs of the other products that you have and what it might be. But C would be the answer, because that bromine in there, being 79.9, really beefs up that number that you're going to be dividing by. So that would be the answer, which I thought it has the lowest atom economy for ethanol. Okay, and that will do us for today on questions with percentage yield and atom economy. See you next time.